So I wanted to give an brief introduction to Django Rest Framework. It's huge and it's definitely not something that I can fit into 5 to 10 minutes. So Django Rest Framework is basically a toolkit for building APIs, and it works on top of the Django framework. So it uses all the Django, the models, the whole of the Django infrastructure, I can say, and it helps in building APIs. All of Django is basically typically towards returning an HTML response. So it becomes cumbersome to actually use Django to return a JSON. And Django REST frameworks basically takes care of all those requirements. In order to get started with Django REST framework, so we need to create a typical Django project first. And so install Django, start a project, create an app. So in this example, I have created the application name as API, and Django is going to create a folder structure as shown over here. So it will create migrations, settings, everything for us. Once this is done, we need to ensure that Django REST Framework library is installed, and then register that or install that into the project that we have created just now. So in order to do that, typically the settings.py file under the Django project that needs to be modified. So in that the installed app section, just add the REST framework at the bottom, and that's it. So Django REST framework is ready to be used. So with this, you can proceed to actually start creating endpoints. So as I said, Django REST framework uses the MVT architecture of Django. So the main components for creating an endpoint are model, view, URL configuration, request, response, and serializer. So most of these components are actually Django components, or the base is Django components and they have been modified by DRF. So they work almost similar to what Django components do. So models are going to be corresponding to, it can be just data, or it can talk to the database through ORM. View is going to handle the request that is coming in. URL configuration basically maps the URL that we are using or the request should have to the view that is going to handle the request. And request and response are HTTP request and response. Serializer you can consider is sort of a replacement for Django forms. So Django forms do a lot of validations and getting the data and everything. So that is something similar. That is something Django forms are not required in case of building APIs. So serializer actually takes care of all those requirements, collecting the data and then actually validating the data. So let's take a look at what is involved in creating a simple endpoint. So first of all, we need to configure a URL. So in this case, I'm taking an example of if we were to return users, a list of users. So that is when you create a Django application and you migrate, it will create that model by its own. We don't have to create a new model for it. So the users if we were to return all the users that are there in our system, all we need to do is create a URL configuration, create a serializer for that model. Now, if you see the serializer, all it takes is we need to declare the model that it uses and the fields. So this is the basic level of what a serializer requires. And then we create a view. Here in this example, I've created a simple API view from using that simple API view from REST framework. I've created my view and declared a get method on that. So a view should have a typical HTTP methods, either get, post, put, corresponding to the operation that we need to do. So here I'm just trying to return a list of users, hence the get method. And so in this way, we are going to have this user serializer. All I need to do is pass in the query set, which is user objects, all objects of user, and it says many, which means it understands that it is going to be a list of users, and user serializer.data is going to return a JSON, which the response, again, this response is, it is HTTP response, but it is it comes, this response object comes from the REST framework DRF, which means it is going to take care of all the JSON conversion. If it's a dictionary object, it converting to JSON, everything, it's going to take care of that. We don't have to do that. So simply by doing this, we already have an API, working API available for us. Now the question comes, most of these components are Django components. So why use DRF? Why not just purely use Django? So if I were to use Django only, Django is it is, most of things are targeted towards returning an HTML, not a JSON response. So if I were to do it in Django, I would still create a view. I will still have the URL configuration and create the get method. But to handle the data, I have to iterate, fetch the objects, all the users from the database, iterate over all the objects. So in the for loop, and then I have to create a dictionary object and give that dictionary object to the JSON response object. As soon as the dictionary, I mean, if I were to consider this example, all I'm doing is returning an email for each user. But if the JSON objects become, or the objects become complex, then it is our headache to maintain those things, and reusability and all those issues will come up. Plus the Django output, if you see, is going to be sort of an HTML response. It's not very readable, I would say. Whereas if you check what happens with DRF, so DRF is going to take care of most of your headaches are basically taken care of by DRF. So if you use a simple API view, you will still need to create a get method, create a serializer, pass all the objects to it. No need to iterate over it. The serializer is going to take care of all those things. All you need to do is make sure that you tell serializer that there are many objects. It's not just a single object. And pass the serializer data into the response. Also the status that we return, right? So all the statuses are standard statuses are actually defined in the REST framework. So there is no need to have stray integers floating around in our code. Furthermore, so this itself is quite simple, and it has taken care of all the headache that we had. Furthermore, actually provides, DRF actually provides functionality specific API views. So in this case, all I have to do is I have to extend or inherit my view from this view. So and then I provide just two attributes to it: query set, which is user objects.all. So we are basically using all the user objects, and the serializer class. I don't even have to declare a get method. The fact that it is extending a list view basically tells DRF that it is a get method. It is going to give a get method only. So that's it. Just in 3 lines, I have an endpoint working for me. I have a view working for me. Plus the output that DRF gives it's a browsable API. So in this example, I had these URLs configured. So there is user DRF views, and since I did two views using DRF framework, both of them, if you see at the bottom, they give an nice HTML interactable UI, and the output is basically easily readable and understandable. Furthermore, you as your APIs get complex, with post it will you will get an HTML form where you can actually input data and create new data. So actually testing your APIs while you develop them becomes very easy. You don't have to have like while testing, you don't have to actually think about oh, do I need Postman, how do I start testing it. It just you already have all those in the DRF built in. Now this itself was very easy. Furthermore, it gives more functionality to us, which is through view sets and routers. Now, typically, what happens with us is while developing APIs, we have to develop APIs for CRUD operations. So create, read, update, and delete. And for any resource, it's sort of the same things that you need to do, right? So this is already taken care of by DRF through view sets and routers. When you create a view set is going to give you all these list of methods, um, and it is going to correspond to the typical CRUD operations that we need. So list corresponds to a list of users that we saw. Create is creating a new resource or user. Retrieve is basically when we want to retrieve a single object, a, let's say details of a particular user. Update and partial update and destroy are like they're self-explanatory, I would say. What we need to do with to get this working. So if we take an example of an event model, all we need to do is in the URLs, we need to declare a default router. So router also, there are different types of routers. For the basic example that we have, let's just take the default router and register a view set with it. And that's it. We don't have to create every or declare every route in the URLs. The router is going to take care of that. Similarly, similar to the previous example, we need to have a serializer, and you can either, and in the serializer, if you see the fields, you can either have all the fields or you can specify which fields you want to uh, interact with, or you want it to be displayed or returned, and a view set. So while declaring view set, again, like the previous API view that we saw, or the list API view that we saw, all you need to declare is a serializer class and the query set, and you're done. So with this view set, it is going to take care of generating all the CRUD operations. You have functional CRUD operations here. So it will send a list of events. It can retrieve an event with event slash ID, let's say event slash 1 or 2. It will give you details of a single event. All these things is restful. So it is going to you don't have to take worry about are the URLs restful or not. So it is already taken care of, which actually helps in, like, in no time you have a full CRUD operation working. Plus it gives you this type of a UI, right? So when you want to test it out, if you see the URL that I have given over here is API events, and it gives me a list of events, and at the same time it gives me a UI at the bottom to create a new event. So I can either do it through this HTML form, or I can work with raw data as well, which makes it very easy to just test while development testing your APIs, and if they're working fine. Now, if you realize that a lot of work is done by the serializer. So all we are doing in the view is declare a serializer, and serializer serializer basically does everything. So in the serializer, you can create two methods. One is create and update. So serializer, right now we saw that all we were doing to the serializer was pass the data to it, and it was giving us a JSON. So serializer can do more than that. Let's say we are creating a new object. In that case, when if we declare a create method for the serializer, uh, none of the code has to be written in the view. All you have to do is send the data uh, into the serializer, like it is shown over here under the create method. If you see, event serializer data equal to request, whatever the data that is coming to us, whatever JSON that is coming to us in the request, we can directly send it, instantiate the serializer with it, and call then we have to make two calls: event serializer dot is valid and serializer dot save. Once we call the save method, uh, the create method that is declared inside the serializer is actually triggered, and in that case, if it is actually going to create a new event object, save it to the database, and return that object. So and it is mandatory to actually return this instance of an object through the create method. Similarly, with the update method in serializer, all you need to do is fetch the object to be updated first. Let's say you want to edit an event ID is 1. So you fetch the event in the view, and you pass that object to this event serializer with the data that needs to be updated. And when you call event serializer dot save method inside the view, the update method gets triggered. So serializer is not going to know that you already have an uh, object instance saved with it, and you're trying, since you have given that object, you are actually trying to update that object. So the update method gets triggered, and through the validated data, it will you need to set all the data on that instance and save it, and again return the instance. So with these sort of methods, the view stays clean, and it's not cluttered with any other data association and update any of those things. So furthermore, the serializer can do validation. So you can have field level validations and non field level valid. So in our example, the event had a title, and you wanted to validate if the title is empty or not, or some other validation. So you can declare event field level validation method, and it will call it on its own. You don't have to explicitly call this method. So when you call serializer dot is valid, it will call all the methods that are declared on the serializer. Similarly, if there are a combination of fields that you need to check, that if the combination, it's not just the individual fields that you need to validate, but a combination of fields. In that case, you can have the validate method and call that method. So again, just to repeat that, with all these validations, the view code remains clean, and view remains slim, I would say. So these are the basic things that you need to get started with DRF. There are so many things that it already provides. So there is pagination, there is filtering. So searching and ordering is already given. All you need to do is declare some one-liners into your code. Authentication, permissions, error handling. Error handling is something that, let's say there is a 500 or a default errors that are going to occur 400s. All you need to do is, so Django is going to by default give and return an HTML, whereas you need to override in your settings.py file and return a JSON. So that is something that is provided uh, by DRF as well. And then there is and versioning. So when I was looking for why to use DRF instead of just Django, one of the things that I realized, or a lot of people had an opinion on the net, although I have not personally used it, was the versioning of APIs is way better with using DRF uh, than just with Django. So benefits, I would say, are basically everything that you need to build an API is already thought about using DRF. You just have to use, everything is already there. They're browsable APIs, and there is enough. There is basically there are so many other third-party libraries that you can integrate with. We are using Swagger for this, so because Swagger gives a very good UI for and a list of APIs. So documentation becomes easy. So Swagger, JWT, Django filters. So these are the kind of libraries that are already there, and there is enough development happening with DRF for using DRF. So although there is enough material, the other issue that I faced was one of the things was nested models. So I had to wrap my head around how to you have nested serializers when there are foreign keys or there are more complex models. That for me there was a significant learning process involved, and there is just too much magic, I would say, with DRF. There are so many things that are happening under the hood that quite often my teammates asked, okay, this is, I have declared this, but where is this happening, you know? So that is something, learning is a little bit, I would say, initially can become overwhelming. Once you get used to it, it's just, it's smooth sailing. Thank you. That's my take on DRF. So one of the reasons, actually, I chose Django and Django Rest Framework for our project was it has so many things already built in.
Yeah.
And since this is a volunteer project, I did not want to people to think about what libraries to use. Everything that you want is already there in Django.
Yeah.
So which is pretty cool and overwhelming.
Let's see. I had a few. One is so you're using this in your professional work, right? Do you find anything that's like particularly hard to do with this, or that you wish they did better, other than say nested models and things?
Yes, one of the things was when there are nested models, like when there is a lot of interaction with there is, for example, you have a user is part of a team, and user has a role and a team. So how do you get all the objects, and how do you create those objects? So the one was actually digging through references was an issue. So once you get to know those things, they don't seem that difficult, but to digging through those references, those sort of references, was a challenge. And other thing was what exactly was, so for filters, like for example, there are so many options that are available, and one was knowing Django itself and how to override filters and how to override filtering issues. So knowing those sort of things was a challenge.
And I guess one other question: the APIs you build, do they tend to be fairly simple? Just the 4 basic methods going directly against the model, or are they more complicated? usually?
No, usually they are again just the typical CRUD operations.
Okay.
So there is only one API which was sort of weird for us. Was there was a validation? There was a link validation. So we are sending a link to the user, and the front end wanted to send that link back to backend and make sure that the link is valid even before we display any UI to the user, which is sort of unusual, I would say. Uh, so for that, we had this big discussion whether to use a serializer or not, because it did not never fitted into a typical model and sort of thing. So the data was simple data, and what we were returning was not even a pretty complex JSON. It was just basically what they wanted was a true or false, whether the link is valid or not. So we um so I did a lot of search on online, and most of people said, why not use a serializer? So most of the community says, no matter what, you use a serializer. But we decided to go against it because using a serializer was making it a little more cumbersome, and without a serializer, it was very straightforward. It was, I mean, readability wise, code wise, it was much lighter. So for that particular API, the endpoint, we decided we'll not go with a serializer.
Okay, thanks. That's interesting to know. Anyone else have questions? Well, thanks a lot. I guess we can clap. It was a great talk.
Nice job.
So sometimes people are afraid to put their cameras on because I think they're afraid, hey, I'm going to be on the final video. If you spotlight individuals, the person speaking, that's like the logical person to be part of the video, only that person's on the video. So if you turn your camera on now, right now, you won't be on the video, and I'll have someone to look at and talk to, which makes my talk a little better. But if not, that's fine too. So everyone can see my screen at the top, correct? Well, I'm sorry, I'll be pointing upward sometimes and looking up sometimes because my screen is up there, but you see the beginning slide for Python infrastructure, correct?
Yes.
All right, so let me go ahead and start a timer too, because I'm afraid that this is going to take too long, so I'm going to have to try to keep it in line as much as possible. I have a few too many slides. With that said, this wasn't actually the original, this wasn't actually the original talk name, and I'll get into that as well. But before we even get too far along, I'm going to make you a couple of promises. I hope for everyone, I mean, some people are very good at some of this stuff and know a lot of pieces, but I'm hoping somebody will learn something they didn't know about anything on the slide here. If nothing else, I bet you will hopefully better appreciate the number of choices for infrastructure as code. You'll actually see what I mean in just a few seconds. Thank you very much. That's cool, Ryan. You're going to gain a PyCon 2022 best practice, as well as that great speech that Ryan had done, that great talk that Ryan had done. And you're going to learn at least one or more useless as a service buzzwords, and one XKCD reference. I'm sure that will be in there as well. And I didn't even mention you're going to at least see one cute dog. So that's my promise to you as we go through with the talk. We'll see at least one cute dog picture as well. And let me try to take you along the path to how we're going to get there. I'm going to first define the original problem I was given. And then here are the bullet points we're going to hit. We might have to skip through some of these pieces depending on how we go. But we're really trying to talk about infrastructure on the problem. So we're going to define the original problem that I was encountered, trying to tell the story around this. And then specifically, virtual machines in Boto 3 library, how does that work? And then how in the world do you bridge from a new virtual machine to some cloud init user data, or even what does that mean? How do you bridge doing things on the virtual machine once it's created? And then do you keep doing it? Maybe we just do it as a separate tool like Ansible to be able to say, hey, this is how we're going to be able to just handle this in a very different way. And then finally, of course, your containers comes up a lot, and we'll actually see containers. And containers is something that's really is the new thing, and really should be lots of talks around this. And then we'll come back and tie it together and review the problem, if that makes any sense. So that's kind of the path that we're going to go here. And if you don't worry about the slides, if you just go to, these slides are all currently in the GitHub, so don't worry about trying to find them. If you really want to find them, you'll have to clone the repo open that, go into slides, and then open the HTML file, and you'll see almost exactly the same slides. I've adjusted a couple, like this slide isn't quite in there yet. But if you want to find that, that's how you do it. So if you want to, and don't worry, I'll show this at the end as well. Quickly about me, Python was my first language. We all have seen that. I do some stuff in DevOps. I currently work for a company that is a large subscription-based music company. I never actually, I got in the habit about 5 to 8 years ago of never mentioning the employee I work for, because not my current company, they're great. But a couple previous company, I always wanted to try to make sure that I did things their way and put in their own blogs and use as a marketing avenue. And I'm like, no, this is my own thing. I want to talk. So I don't ever mention my name again. But I work for a large music streaming company, and it's not Spotify. See if you can figure it out. But I also own a small company that is really small, and it's we're actually going to rename it Blueprints Operations. You'll see what's going on with that as well. Anyhow, that's me. No big deal. And Jeff, this is that slide I mentioned a few moments ago. Am I an expert? I don't know. Often I feel like the first picture. I'm not sure if anybody else has ever seen that very first picture where it's like, hey, this is what I know, and this is what everybody else knows outside of me. But in reality, especially when it comes to so many pieces like this, we actually know that what I know overlaps with a lot of other people know, and that, it's very distinct. And I will actually refer to this one a few times because honestly, I am sure that there will be something in this talk that I learned that you knew that I didn't know. And yeah, Karen, I love that graphic as well. That is definitely something that struck home to me, and I will show it a few times for sure. All right, so let's talk about a story around this. So I had a particular customer, this is through my own business stuff, and they didn't do infrastructure as code. And we'll get into what that even means. But basically, all this code that's up there, they wanted in their code base. And they wanted to do it an entire site, an entire system, really not a website, but really an Amazon system. And they want to do it with TypeScript. And we'll see, how can you do that? How does that work with infrastructure as code? Is it possible? Yes, it was. Pulumi is the one that said, hey, we can do that with TypeScript and everything else. And so did Python. I got excited. I'll get paid to learn something new. Well, I won't get paid to learn something new, but I'll learn something new so I could use it. That's always the excitement of doing contract work. I learned something new. That's exciting. And then I use that thing and I'll tell someone new about it. And I'm like, Jeff, I'm learning something new. Best way to motivate me, do a talk. And so that's why I hooked up to do a talk on Pulumi. Notice the title is slightly changed, as we will see as we go through. And the reason the title is slightly changed is because there are some interesting things that came up. But anyhow, that's the framework of how we're going to tell the story. And I think you'll see a theme. As everyone knows, to keep it very Python related, and there's a ton of Python for most of these tools we're talking about, is the only one, I'm not sure if everybody knows, import this. The one particular line out of import this that comes up a lot these days for me is there should be one, and preferably one obvious way, and it's not scroll over, sorry about that, to do something. I didn't have the next line unless you're Dutch, which is funny as well. But this is the actual line out of import this that I want to focus on because it feels like there's so many ways to do things. Like Perl had a million ways to do the exact same thing. It was so confusing. Like if I knew this way, somebody else did another way. I feel sometimes in infrastructure as code or even in Python packaging, there's many ways to do something. It can get very confusing. Oh, and there was something I learned for PyCon about that, which we'll get to as well. And so I'll jokingly say one way to do something. I'm not sure if anybody knows the structure pattern matching tutorial that comes up, but this is a particular PEP that came up. And I'm like, wait, one way to do something. This almost looks like a case statement. Guido hated case statements. The one thing about having a benevolent dictator for life is there was only one way to do something, no more design by committee. This will be like not a lot of different ways, but one way. Even if I don't like it, it's like having a style guide. Even if I don't like it, there's just one way. And I'm like, wow, there's more than one way, until I went back and realized it was actually sponsored by Guido as well. So never mind. Exactly. So it's still, it is still very much the one way that very matches. So if you want to do a case statement, that's a particular way to do it. But again, I really like this style of, we'll have lots of people talk, lots of input. Let's hear everyone. Let's try to pick the best choice. And I realize that these days we have to give references for those who don't happen to know. This happens to be a character from a particular television show in the past that had always collected all of the different answers, but then chose the answer. And that once that decision was made, it was good. He was very good at listening to everyone. But after he listened to everyone, he made a decision and we moved with it. And that's a theme that I'd like to continue with. But let me actually just rewind again for another second. There'll be a lot of weaving this story together today. Yeah, that's true. There's also a current television show out about him as well. So maybe people do know who he is. So we gave a talk. We actually had a talk, and I actually thought that this felt like 20 years ago or something. I went back to go see when this talk was, and it was only in February of 2020. So this was right before COVID. This just tells you how much the COVID has changed so much, where this particular talk seemed like it was 5 years ago or 3 years ago. It was literally a couple of talks before we stopped meeting in person. And it was basically about how to develop the Kubernetes Python client, which was an incredibly good talk. And it was all about this. And a lot of the questions we were asking in the audience was almost as basic as, what are containers? So if we didn't have the basic of what are containers, how to write a Kubernetes Python client wouldn't have even made sense. So what I'm hoping to do is to kind of spread this out a little bit, get us all kind of bootstrapped out, and put the Kubernetes on the back burner for a bit, talk about how all this works, and then come back and tie that all together at the end. All right. Also, a framework that we often talk about and the things that I work with, just try to keep it organized into sections. I'm only going to touch on this. This is what we've done on, I think, December's talk as well, just to kind of say, like, once the code is released, we now have a brand new Django Rest framework that was just released. It works on my laptop. It's ready to go. Well, really, is that the only thing to go? Once it works on my laptop, what's next? Now, of course, I need to build it. Not really a lot of building for this. There's maybe a packaging. Maybe we'll have to do a set up py build and put it on PyPI, maybe. Test it before we even put it on PyPI. Releasing, then deploy, operations on it, monitoring and plan. And then above all of this, there's really the idea of security in every single facet. This is how things are organized. And also, there is something called GitOps, which isn't really related to this as well. And this is actually one way to look at it that might change depending upon how we look at containerization as well. So a lot of pieces. Go back to that graphic if it feels like everybody knows more than I do. There's a lot of pieces here. Staying focused, we're going to really look at what I will call infrastructure, and that is release and deploy, the yellow pieces here. And we're going to build the infrastructure so that we can handle millions of hits to our Django REST API. And I just mentioned, several. We definitely need to have these several elements. We just said security. BizOps is a term that comes up a lot as well. There's just a lot of terms in this business. It seems like there's just keeps going. It's like bingo. Everybody gets a bingo card. All right, so let's go ahead. It was the last talk before COVID. So if anyone sees me responding, I'm actually looking at the chat at the same time I'm talking. So literally that was our last talk right before COVID. That surprises me. That's probably why we never got the video for that one after all. Okay, interesting talk. It's one of my favorites. Let's just start over. Let's just start from the very beginning. So for the next couple of minutes, hold on to your seats. We're just going to talk about how we talk about software and we talk about infrastructure. What in the world does that mean? We'll go real quick, but try not to go too quick. So in the olden days, when we had to walk to work both ways in the snow, uphill, there was a particular big server rack. So you had to put everything in the racks like this. And I didn't get a good picture of racks. But basically, you just have all these 1 unit or 2 unit, like these machines that just fit and bolt into these racks. And then, to get this going, you would have to sometimes, if you're going to go through Rackspace, I remember using them years ago. They're still around, by the way. And I think a lot of times you used to negotiate contracts. So I want to have 3 new racks, and Rackspace would say, okay, great. And that's a commitment for 2 years since we have to buy the hardware and things like that. And so this would take a lot of time to physically put things in the rack, to put an operating system disk in and have it load with whatever your order form is. And then people would tell you, hey, this is what I want. And they would turn around in weeks to give it to you. Yeah, it was a sunk cost as well, meaning that, once you couldn't just use it for 5 minutes and come back and call it. It's like your electric. It's not like your electric bill. You pay for only what you use. It was a sunk cost. You paid for that no matter what, even if you didn't have anything live for a while. But then we all know that you have a way. Like I bet you, if we were to just use the just for fun and to break things up a little, does everyone have reactions anywhere? Do you see reactions? If you see a reaction, raise your hand if you've ever used any one of these softwares just to make another computer on your hand. Oh, good. I see a hand. Good. 2 hands. Excellent. 3, 4, 4. Okay, great. So we've all at least seen these things, VirtualBox or VMware or Parallels, or in my, or Linux, we have KVM, Zen, QEMU. There's just a ton. One way, lots of options, So we can at least build a software that emulates another computer system and show it. So we don't need to belabor that point. Really 2 ways to do that, though. And this is kind of important to zone in on a little bit as we get further in the talk. So the one on the right is what we just mentioned. So I've got my hardware, I've got my operating system. So let's say it's my Windows computer and it's running, one of those programs like VirtualBox, and that's actually running its own operating system. So you have, an operating system running software that actually has its own operating system. And sometimes that was actually simulated other hardware as well. But you'll see in a lot of these big systems, you'll also see, I don't know if the hands are up just for a question or if those are just from before. So sorry if I'm missing someone's question. Go ahead and type it in if you want as well. Oh, and news, it looks like VMware just sold for how much is that 61 billion? Wow, that's pretty amazing. So on the left, you'll actually see that we will have some hardware and then it's not even an operating system, just a small program that just is supposed to be used for this stuff is installed. And I deal with this kind of stuff a lot in my day job. It's very interesting. Again, just to remind us, it feels like we're doing a lot of things. I'm sure I get, every time we hit all of these things, it feels like everybody knows a lot more than I do. I just mentioned I'm doing a lot of overt, kubevert, and RHV on some of the stuff on the left. That's not even part of the talk. Just don't worry if it feels like we're throwing a lot at you. That's how it goes sometimes. Ignore it. It doesn't matter. It's magic. We will somehow have some software that we do that will create this other thing for you that will give you a machine and an operating system. Doesn't matter how we do it for this particular talk. Just know that there can be software that would build that on the fly, and then we don't have to do that whole thing we mentioned before, which was sign a contract, wait for someone, etc. That kind of thing. And in all these different software pieces that we had to be able to try to say, hey, how do we build a virtual machine in the cloud? Well, how do we do it? I think it depends heavily upon the vendor. Well, we should make a standard, so it's a particular one. Yeah, well, which standard, which vendor? People are fighting for your eyeballs all the time for this. And so you're definitely competing standards all the time. And so how can we show all of this without going crazy? And we're just going to pick a vendor. We're simply going to pick one vendor and work with it. And I'll pick the same vendor that my customer has used. But we also have some other vendors who are in that same space who've hosted us before and given us lots of, meeting space. There are lots of good vendors for this. I'm just going to pick one that my customer was asking for. And also the Gartner group said some very good things about. There's a lot of vendors here, and there are a lot of pieces as well. And there's a lot of S's. What? So everything after, so you see AAS everywhere, that's as a service. Probably most people know that. And we can just quickly look at some of these. Software as a service, okay? That's like Gmail, So if I use Gmail, or if I'm using QuickBooks Online, I don't have to install the software, I'm just using theirs. So that's like the whole thing right there, running in the web, running in the cloud somewhere else. That's the whole service. A function as a service, which is kind of new. If you've heard of an Amazon, like if I want to make a Python function and just let you run it, you quickly just hit this thing, run a function, it starts and it stops, that can happen. That's a function as a service. There are functions, like Amazon Lambda is a perfect one. AWS Lambda is I just had a very old Python 3.6 that was deprecated, or was it? I can't remember. I think it was a 3.6. And Amazon's like, yeah, you can't use this service anymore. It's deprecating. It's going to stop working. I was like, I didn't know I had that function for that version. I went to go look, and it was a demo I gave a friend about 5 years ago and forgot about. I went to go look at the logs to see if I was paying money that I didn't need to, but nope, no money. No one was using that function. So you can have just a function in the cloud to do one single thing if you wanted to, and it's very cheap since you only pay by the number of times the function runs, and a couple of other small things. Data as a service, desktop as a service. Let me just check time to see how fast I need to be. Yeah, I need to get going. So there are a lot of pieces here. We're going to go through, pick these vendors, but just quickly, I'm just going to say, look, Amazon Web Services is the one that had the most Gartner's completeness of vision and ability to execute, according to these outside people called Gartner. They picked AWS. Google, Microsoft, and AWS are on this leaders quadrant, which is perfect. I'm just going to pick this one again for my client. So when we talk, we're going to talk about Amazon, and because it's going to just make it easier not to talk about a million other things. Oh, and GCP. So just like a second ago, we were talking about here having an Amazon AWS Lambda. Google has GCP and they call them cloud functions. So we could pick any vendor, lots of good ones, but just for simplicity, I'm going to choose AWS for this particular talk. All right, a lot of stuff. I don't know how we're doing. Thank you for bearing with me. Let's keep going. We're going to need a couple of prerequisites for this. And we had a talk on that too, which is good. Virtual private clouds is some place, a network that we're going to need something. I'm going to hand wave that simply because of time and constraints. But if we want to, I'll even do some office hours afterwards. I'll show people how they can make a VPC, and there's a GUI that makes that a little bit better. We've named ours Bay Piggies Demo VPC. That's pretty easy. The address space is the default one. Okay, a bit overkill for our demo. I don't know if you guys know how that CIDR looks, but that's a lot of private email addresses for what we need, but that's okay. That's the one that gets built by default. If you just go through a little GUI, you type in this name, auto-generate, you let its default blocks come in. You can just choose, if you will, VPC and subnets and let everything happen for you. And if we scroll over, we see that it gives you subnets. We need a public one for what we're doing. You always have 2 for load balancing. Route tables, we can ignore that until we get further on. Internet gateway, which is good. Oh yeah, I need to make sure to kill this when we're done so I don't pay extra money for that. And so basically all of those things are just going to be built for us as a prerequisite. Doesn't matter. Done. Next, we need a firewall in the cloud. We're going to call it the Bay Piggies Demo Security Group. Okay, that's not the most exciting security group, but that's it. It's going to be from Glen's office for SSH for connecting, and web traffic. We're going to be a web server from anyone on port 80, not on port 443, not for this, and that's okay. And it just happens to have this ID. Yeah, and we did this by hand because we're just trying to show how quickly you can do this with a GUI. And the third prerequisite is that you actually need an SSH key. Yes, I could do SSH keygen and generate my own, but I'm just going to let one be created so it has the public key already there, download the private one. Sure, I could actually do that the other way around, so I am in control of that. But that's okay. I just want to have a public key ready so that when I connect to it, I can get into the cloud. That was just the prerequisites. So let's now try to just make some decisions, some choices. There's a million different kinds of machines you can buy at a store. I'm going to say general purpose. And I'm going to pick the second family of general purpose because for my demo it was free. It didn't cost me anything because of a free tier, a discount I have. You could also have chosen memory optimized, storage optimized, it doesn't matter. You're going to see the word T2 sometimes, that's all. Also, we also need the size of the machine. How much memory, how much space is going to, just think of it as a t-shirt size, small, medium, large. In our case, something I couldn't fit into, I'm going to pick a micro. So I'm picking a T2 micro just to have sizes. Hard drive, 8 gigs is fine. We're just picking some kind of basic. And then the default operating system, you can choose anything. This could be Ubuntu, this could be anything that you want, but I'm going to pick Amazon Linux 2 because it's default, because it's free, and also because it's based on RHEL, which is a lot of corporate stuff uses, which is fine. And where in the world is going to be US East 1. Okay, so just some stuff I've picked just for this demo. Keep it simple. All right, now we can actually start looking at some code. All right, subnet's already created, so there's the variable for the subnet. Super easy. This is all in the GitHub repo, so you can actually look at it. When you run it, you'll have to change this or it won't work because you'll try to use my subnets that won't exist anymore. This is just that weird, this is to say, hey, this is Amazon Linux 2. This is very close to this is very close to a Red Hatty kind of thing. It doesn't matter, but the Red Hatty kind of thing without the licenses. And then the security group is the thing that we picked and chose earlier, which is going to say, hey, look, this is port 22, that's SSH, so I can connect from my office, and port 80 from anywhere. Again, it doesn't matter. You can set those things up easily. That's just 3 variables, 3 equals, simplest code ever. I need to pick a hard disk. In this particular case, and so far, all we're looking at is that variable string value equals. Super easy Python code at that point. Now, it's a list of dictionaries. I can have more than 1 hard disk. And so the dictionary is going to have a name. Okay, that'll be my root hard drive right there. And it's going to be, that just to mean that's the service in Amazon to say block instances. It's just a way of saying what kind of thing it is. One of those choices that I didn't put up here that I thought I did, but I cut out, was the type of volume, general purpose. Good enough. There's several different specs if I cared about that. People in my job are always much, we have our own data centers and people are much better at hardware than I am. I work for a team and we do a lot of like, oh, I'm going to pick, I mean, I didn't even understand what some hardware was that was pretty laughable until a year or two ago. I won't even say what it was because I realized it'll be on recorded and I'm embarrassed. But go back to that little, everybody knows different things. All right, network interfaces. And this actually is something that has changed. If you Google in Stack Overflow on how to do something, you will actually very easily see people just putting something directly into code, which used to work but won't. This is actually a little bit different. And so this particular one is just going to, I'm going to pick the subnet, I'm going to pick the security group, and I'm going to say, give me a public IP address of true. That's another dictionary that I set up. Oops. All right. And so I feel like I've messed something. I think those slides are out of order. So I will come back to this particular slide and say, okay, I'm going to import Boto3 library. There's a whole URL. If it's not pasted, we will paste it and show it to you. I am going to pick the US East 1 and just choose the variables I already picked out, like T2 micro. I only want 1 machines, network interfaces I picked. This is enough. If I were to just basically use this library on run instances, it will build those for me. And I could even, you know, yeah. I'll cut that other slide out. That's just going to confuse us. So we could just builds us for us. All right. And so the response itself is going to hold the answer for how many machines were built, what's the IP address, etc. All right. And so I am going to say, let me just loop through that and just print out the more interesting things. There's a whole bunch of information comes out. I'm saying, just let's look at these interesting keys. They're all interesting, but just interesting from my point of view. For every instance in that response of instances, give me the instance ID. That's something that Amazon uses for an ID. And then, hey, this is from the GitHub. If you want to start your debugger, you can actually just start popping in and see what the response is before it goes away. How many people have used PDB before? 2, 3, 4. I see 4 hands, 5 hands. Oh, wow. Lots of hands and thumbs up and claps. So PDB is not new for us. That sounds new. If anybody's interested in learning PDB, I'm sure we can find a tech talk for that. That's anybody wants to give a tech talk. I'm sure we can. Jeff, I don't want to speak out of turn, but I'm sure you wouldn't turn down a good tech talk on PDB. And what's interesting is that this API returns before there's actually a public IP address. You get a private one, but not a public one. So if you'll see this demo, you'll actually see that this public IP address is blank. You don't actually have anything. And so we can go back and, you know, query things and look for things. Again, I'm trying to keep this high level without being dry as paint to look at all these different places of this API of what it works. Oh, excellent. We have a volunteer. We have a volunteer for a PDB debugging talk. Excellent. So this is basically the information you get back. This is the thing that we made it. This is the Git repo you'll see. So you can play with this on your own. T2 micro, there's the key that we're using. There's the actual internal IP address, but I'm not currently connected to the internal IP address. If I had a machine in that cloud, in the VPC, I could, but I'm just going to work locally. It's still building, it's still pending, so eventually complete. It's coming back already. The hypervisor happens to be Zen. That's interesting. And the hard drive is on XVDA, so it's very much like if you ever look at dev XVDA or dev VDA, you'll actually see that that's the first drive, or LSBLK. You'll see the drive if you log in. And here's how I connect to it if I had this one, but it's kind of blank yet. So we have to wait, go look at the UI, whatever, but pull that up. All right. Again, I would love to show you, this could be a talk on its own, but we're just kind of trying to go through, show some background, work our way up to a few other things, and then come back. All right, and so SSH, using my magic key, so much, there's so much we could talk about this. We could actually do a lot of hands-on things with this. Even some background on how to use Amazon, setting up and accounts could be done. And I'm happy to do office hours with people to help them with this. But either way, I've connected to the box. This is where I'm in. This is what the logo looks like. And booyah, I now am ready and I have a box and I have a prompt. Yeah. So that's how I get a VM in the cloud. However it works, it's magic. We get VM in the cloud. Hey, it looks like this one comes with Python. Oh, but that's 2. Well, that's interesting. That is actually how these old ones are. Believe it or not, I see a lot of that. Also, Python 3. So I explicitly picked Python 3. So, because we all know that Python 2 was end of service, what, 2 years ago now? Long time ago. So Python 3, obviously, is best. I don't have to use the API. If I were very much a command line person, I could actually say, let me just use this command line tool and describe those instances, and I would get all this information right back. In fact, look, image ID, instance type, you would get all that information back. So I could have used this instead of querying and polling for the IP address, the public IP address when it was made. I could use this and be able to get to the actual IP address if I wanted one back here when I was trying to say, well, what IP address did I connect to right here? Because I needed to be public to connect to it, but, well, I didn't, but I did use it for this demo to make it public, but I actually said only from my IP, the only thing that can be public is from my office IP. And there's other ways to do it with private, which is even better, but I'm trying to keep it simple. Okay, I need a talking break. That's what this slide is, talking break. Anybody have any questions for a second?
Yeah, Glenn, I have some questions. I've tried to mess with Amazon, AWS services so many times, and I feel like I always just get in these little ruts of like one connection's missing to, some gateway here or there.
That VPC especially, yeah. If you're having to build your own VPC and internet gateway, and you're trying to say, like, I just won't connect, yeah, that little GUI I gave you above in the slides will help with tons of that. But don't forget to destroy it, because you don't want to leave an internet gateway around. Just like a virtual machine, you want to destroy it so you're not paying money at the end of the month going, what happened?
Oh,
If you have any more questions, but try to use that little GUI, make your own little VPC, use it, pick a public subnet just from these slides, and I bet you it's not 10 times easier.
Wow, okay.
And that's something their UI has been better. They didn't change their technology, they just changed the interface. It was really, really hard. You had to understand like a whole degree in networking just to be able to build a machine, and which is very confusing.
Cool, thanks, Glenn.
Sure. All right. Just to give everyone a framework, if you have a quick question, go ahead and I'll give you a second to do it. But we had a customer, they're on Amazon. I was trying to say, let's just kind of quickly, we were like, what are containers and what does all this work? I just quickly want to hit some technology paths, just kind of work our way up. And this is not supposed to be like I can do EC2 Boto 3 from scratch. It's just, hey, it's possible. This is the guidelines. This is what it looks like. Clearly, we can do an office hour if you're ever interested. I do them all the time because I love talking to people. I think Chris and I did one recently, or did something like that recently. It was super fun. Virtual private cloud. Yes, virtual private cloud. Thank you for asking that. Very good. VPC is virtual private cloud. It's your networking stuff where you put stuff into it. No, it's all good. It's perfect. Trust me, those acronyms that they make up are very, very weird. That's perfect.
I was going to guess cluster, so.
Fair enough. It's the actual cloud. VPCs are free. Amazon doesn't charge you for those. It's the networking framework that you put everything into. So it's not the cluster yet. It's just the virtual network and the things that connect to the virtual network. It's an address space and some things that connect to your address space, some networks that are plugged in that you basically plug your machine into. Yes, cloud are made from computers. It's true, but if I can have virtual computers as well. Can you host Docker containers directly? Yes, you can, and we're going to get to Docker. I don't know what that is yet. All right, good. Docker, haven't heard of it. All right, now, welcome to 2006. This is not exactly new. This is it's new that they actually made the VPC easy to read, but making virtual machines in the cloud is not how a lot of people do it. That was something that we did a lot, even though we have them. What if if I want to upgrade an operating system package or install needed packages like Python? Well, two things. First, this is how we get a virtual machine. But if I had built this virtual machine, I think we were supposed to do Django Rest Framework. How did that happen? Do I still have to SSH into that box and then say yum install or apt install or pip install? I mean, if we're supposed to really truly be automated, you automatically create a network. I'm gonna slow down. I realize I'm talking fast again. We automatically create a cloud. We automatically can create virtual networks. We can actually create machines, but we haven't configured those machines yet. And we're trying to basically say from code, everything in code represented in a way that I simply could click a button on someone could get clone Glen stuff, and then their cloud and their Amazon account, they have the exact same thing all built and just runs, and even a web page is hit. So operating systems, upgrades even, Python Nginx, installing Python packages, applying database migrations. If you ever did a Django, like if you're ever deploying Django, quite often you need to do these database migrations, and you need to compile the assets and maybe even push those assets somewhere. So there's just a lot of things that we need to be done, and that's not really part of this. All we've done is used one library to build the cloud. Make sense? All right, so how do we do that? One way to do it would be to use this thing. Can you see my mouse as I move it around up here? I'm dragging my mouse on the screen. Yep, okay, good. So user data right here looks like a Python script. So call any Python script, and then it's very simple. Temp this thing is this thing on, and then there should be one, and preferably on one, obvious the way to do things. But so far, we're not getting just one. It sounds like we're getting more. So how do we fix that? I see a lot of people do this unencoded. It still works until you do one little character that throws things off, and suddenly it doesn't work, but you don't know why because you don't know how to debug. So best thing to do, import base64, and then encode your base64. But don't forget, you get bytes by default. So we'll want to encode as ASCII and then just go ahead and pipe through here. So basically this script, I'm saying a lot, so let me just pause and just kind of focus on a couple of things. When I build this machine, I want to kick off that script. Could that script be something bigger? Yes. Could I do everything from scratch through this script? Yes. Basically, when Amazon starts, it'll actually pull that down to that machine and kick that script off, whatever you write. So really, you could do everything yourself this way. And sure enough, after 2 bugs of my own because of an encoding error of a mistake I made with new lines, because those things happen, after I logged into that, sure enough, I got that, and I forgot my new line here after fixing that bug, but I like, that's okay. It shows human error. So I didn't put this in my script earlier, and if you put it in, you'll realize that it's actually, you gotta double quote it because, anyhow, whatever. It's alive. We could Frankenstein this, and trust me, I've worked on stuff that has been Frankenstein like you wouldn't believe. It's crazy, but we're trying not to. We want the one clean way to do something. What happens when the Frankenstein fails? This is all something that uses something called cloud init. Cloud init is something that almost every vendor, VMware, Red Hat virtualization, I can't think of a vendor who doesn't use cloud init to basically stamp the virtual machine or the way you want. Cloud init alone is awesome. Most people don't even know that cloud init's a thing. Cloud init output log right here, var log cloud init output log, is going to tell you what happened. In fact, from the very beginning, it will tell you exactly what Amazon is doing or whatever vendor you're using. For example, you're booting up something else. You're booting up your net device, blah, 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 blah. And if you look in that log, you'll see that there's other logs like, I hate that this is wrapped around, but you also have just the cloud init log itself, and you have the cloud init output log. Both are wonderful logs to see what's happening. This output log will show you the errors that you're like, why did I do that? I can't believe it. Can't tell you the number of people who get stuck because they cannot find why this script is not doing what they think, and they have no way of seeing it. And it's right here. We just don't know where to look. And guess what? Cloud init is a Python project. There could be an entire talk on cloud init, and if someone wants to see it, I would love to attend it because I need to learn cloud init better, but I'm not volunteering because I don't have time. But I would love to have that pressure to learn it better, or to watch someone else. I can definitely use cloud init, but I use it as a consumer. But if you start looking into its code of how it works, there's several structures I don't really deeply know, and I would love to. But this Python tool is the crux of almost everything we're talking about. But I'm going to give you a warning, and that's just dog pictures because I want the slide to look better. There's no other meaning than that. Cloud init is to building infrastructure, what I think WSGI is to web frameworks. Well, okay, not really. Close enough for this talk, and I said that. That's all. So if you know what WSGI is, and that gives you a little bit of an explanation, is like, okay, I don't use WSGI, I use Django that uses WSGI. Well, I'm not going to use cloud in it. I'm going to use other things that use cloud in it, and that's kind of where we're going to go. All right. And I have seen people now with Python, with this is like a crux. I spent a lot of time trying to make an example up for this, and I just couldn't. The thing is, I see so many all the time. I can't tell you the number of people who says, I get this to work, and they get it to work once. But every single time you have an assumption, and your basher is not error checking, so that assumption failed at this particular time, and now this condition is no longer true, and that keeps going. And so we just have to debug, and so much human effort is wasted just trying to bootstrap this thing, and I don't think we ever should. Think about the math. Even if our code is 95% reliable, which sounds good to me, 95%, I mean, I'd put bets down for 95%, but if I have to have 3 pieces of things that all have to work together for something to work, that are 95%, each of them are 95%, that multiplies. That's how the probability works. So that really comes down to 85% reliable. So the more components I have, the less reliable it is, because there's a chance for each one of those are failing. If I had 7 different pieces here, we're down to 70% reliability. And this, it's like sleeps in code, things that just drive me crazy. Sleep conditions that sometimes work and sometimes don't. Don't get me started. I'll talk about sleeps in code a million times. Don't do a sleep, wait for a particular event. Very much like this, you're going to see 70% reliability because like it works. Well, sometimes. Well, why doesn't it work? You're going to get better reliability by making some different choices. So the summary is, sure, we got a Frankenstein alive here, but that's not how we're going to do it in the real world, right? We're going to pick tools that use this, and we're going to plan for failure. I believe that there are 3, and some of this is parroting other people, some of this is summarizing other people, but I realize as I wrote it, this is also very true. 3 things is going to make this much better. Plan for failure, because it's going to happen. Network stuff fails. No matter how good your program is, if you're going to do a network glitch, how many times do they eventually fail? It's just a small glitch. If that's going to throw it off, that's going to, that's going to just make everything fail. What if you just tried and waited half a second and tried again? Or what if you even exponentially backed off and tried again? It makes this a little slower, but if it's a failure on something outside of your control, then this is better than just failing again, because you might be at steps 100 steps of my crazy script, and I'm at step 98 and it fails, and I didn't get the last one. But none of the steps 1 through 70 where it doesn't work because the preconditions already existed. That some of the stuff that was made doesn't already exist, and it's just crazy. So don't do that. And per everything I just said, don't just make this, don't have global variables, very much like I would tell a new Python person. Don't have global variables everywhere. Use functions and keep the scope within functions. Very similar. Organize everything into logical components. Keep everything very logical. Keep it organized into more logical components. And I am so running behind time. Okay, now also I'm going to make every component idempotent. What does that mean? Idempotent means that if I do it once, I should be able to run exactly the same. I should basically, let's say I have something that sets a variable. And if setting that variable makes it fail, check if the variable is already there, or do a try except, or in some ways make the thing run the same way. If I run it once, I get one result. I run it again, I still get the same result. Always try to make it so that at the end of the step, I get the classic thing done. I don't have all the other stuff done. And yeah, I just thought it was cuter to have a dog in the picture. So what does all of this really well? Ansible. And oh my gosh, I'm going to just run through this because time is going and Ansible is the one that's going to get the axe. Sorry. So here's the idea. Every machine, here's what Ansible tried to do. Tried is the operative word. Every description of the thing in YAML, because it's outlines, and humans like outlines. It's a logical. Everything should be an outline and easy to read. It should be logical as well, and idempotent, so it's easier to use, and the components are loosely coupled. And this is an idealized example. This is not Ansible. This is an idealized example where I'm the person in a meeting and I'm like, well, what is web server? That's just what I call it, web server. Okay, it's a boring name for a web server. Now, I could have called it Fred, but I call it web server, that's it. But what is it? It's an operating system of Ubuntu 20. Great, 2004. What software is on it? Well, the application software is Python 3, version 3.10.3 specifically, and it's a virtual infrared over here. All right. Oh, and it has an application root right in this particular location for what it needs. I don't know, made that up. Unicorn, number of workers, 3. Made that up too, but it often makes sense. You'll see these things as well. And then Nginx, the thing that sits in front of your application, in front of our Django Rest, it's going to have a web root and some kind of local file that's a configuration for what that file looks like. I think this is easier to read. It's what Ansible tried to be. This is real Ansible. Not terrible, but less declarative. So here we have each one of these tasks is idempotent, like we said, or supposed to be. They're actually not sometimes. Depends on who wrote them. This isn't called package. This is very specific to Debian style. So that's not it. There is a package though, but I just grabbed this playbook from someone else. And it's going to install Nginx to the latest. Do these use the idempotent language, or are these using the imperative sense where it's like, update cache feels like a verb to me, but it's trying to say is the cache is updated. So it's very weird. It's like we try to use, like in a git commit, you try to say the imperative sense. So I could argue that's fine. Either way, it will go through this step first, and then it'll go through this step to copy the website files. It'll apply the Nginx template. It'll enable the site because that's what you do in that stuff. It allows for TCP ports to be open inside the computer, not on the firewall I mentioned. And then, of course, there's a handler, which is very procedural, but actually at some point it gets triggered, it'll restart it. So is this idempotent? Yes, the steps are. You run each of the steps, it still works. It definitely has flaws, but I've made my entire career, well, the last 3, 4, 5 years, just being an Ansible. I would say I am an Ansible expert. I spend almost all of my time doing all of this with Ansible. This wasn't my playbook, though. I borrowed it from someone else because it was easier that way. And you know, if I were to come back and look at something we just saw, it's fine. We're out of time. I don't want to go into those concepts, but that's how this is. I believe personally, and I think most of the tools do, if you're actually building EC2 infrastructure, a lot of people out there like Terraform, for example, or other tools will say declarative is better than imperative. And that's a big key to the argument later that we're saying. You know, SQL is a famous example where they're basically trying to say declarative. But for the very first time I looked at this going, wait, is that declarative? Select feels like a verb, but it is. Everything is declared. You aren't making choices how this selection is being made. An optimizer in the engine is doing that. You're just saying what you want and somebody else is choosing how. Anyhow, what should exist? Imperative is how to get it. I feel like this is a reminder to myself. There's a lot of stuff going on. All right, fine. A lot of people know lots of things. Questions? We're about to pivot to the final concept, and I'm already over my time. So how does Ansible handle sequential dependency? Great question. If you don't mind, I will hold that. But ideally, you don't have sequential dependencies, that each thing is loosely coupled so that it can handle and do, like each task is idempotent and it doesn't need to have that external dependency. But if it exists, it does something smart. So that each one should be smart enough that handles that external dependency, and then you loosely couple them, meaning that if it exists, I'll still do the right thing. If it doesn't exist, I will do a different thing. Sometimes people break that, and I see a lot of stuff there. Anyhow, sorry. Is it better for me to break and slow down, or is it better for me to just march on forward? I know there's a lot of technical stuff being thrown at you. I know it can be boring to look at a bunch of slides. I'm over already. All right, let's go. All right, so this is basically a, I want the one way to do it. One way to do it, we're still talking about things. Everything we talked about was building a virtual machine in the cloud. I went to PyCon this year. And PyCon this year, don't forget, we're going to need to come back to this in a second. This native one hypervisor, we kept coming down to one particular question that I just really want to find the one way to do something. But before we go there, let's talk about containers. Ryan, you asked about containers. Let's talk about containers. I'm going to give 5 seconds for everyone else to understand what the difference is here. Actually, this needs to take more than 5. I need to take my time on this one. Notice that you have the hardware, and then you have a hypervisor. It's not even a full operating system over here. It's just something that installs like an operating system, but its whole purpose is just to run the OS. All right, but you still have an operating system here. What if that hypervisor was just one single OS, but each of the items up here didn't have an operating system? Okay, that's kind of been in someone's mind, so let me just say it this way. What if I had hardware? What if I had one operating system on that hardware, like Linux, and then instead of having a hypervisor, I can directly run whatever virtual machine, not even a virtual machine, I can directly run whatever code or thing that I want without actually having to install the entire operating system or entire hypervisor. It's very thin, very lean, and much smaller depending upon what you do. Docker was first announced, by the way, at PyCon. It wasn't called Docker at the time, in Santa Clara, if anybody remembers that. I remember that talk. I was there in the audience when they talked about it. Didn't quite understand all the significance at the time, but my coworker did, and he was like very, very excited, and it changed everything. And that company got bought, by the way. Very, very good for them. This is what we're talking about. The kernel itself is your operating system, your Linux. There's something called C groups inside of your Linux. Again, magic for as far as we're going to go to now. What each container using namespaces and C groups basically looks like it's its own little operating system. I even hate saying operating system, even though you have a very tiny bits of operating system. You have just the bare minimum it needs to run what you want. And frankly, you might not have Bash or LS on some of these. It might be very, very lean depending on what you want to do. It just runs what you want to run. And we had a talk, very recently we had a talk to, I think it was last month maybe, or 2 months ago, we had a beginning talk on like, what is Docker and how does it work? So you have this particular file where you start building, basically it's like defining your operating system. I say that in quotes because it's not really an operating system, it's the tiniest piece possible. Really, it's just a process on your OS. But basically, you're just going to take some base image, some base little bit of a hard drive. In this case, Python 3.9, that's all I care about. And this is an operating system that's very tiny. So Python 3 with very, very little operating system around it. I'm going to make a directory. We know what that does. The slide has very bad syntax highlighting. Star threw it off. This is all still good syntax. I'm going to copy everything in the source directory. This is in the repo, so you guys can play with this on your own, into this directory I just made. This is going to be the working directory I'm going to work out of. And I left you a couple comments if you wanted to add bash, because this one doesn't have it by default. It has sh by default. And if you want to do some other things for later. And then quite literally, you're going to run Python. Notice I didn't use a VNV, but I could have. There's a question there. And I'm basically upgrading pip. And then I'm taking the requirements, and then I'm just making that executable. That's all that tiny thing does. And if I have a lot of those, that could be a lot more efficient. And regardless, I think at this point we can say this is the one way. Here's how I would build it. Oh, you'll see me seeing Podman a lot. Podman is the open source equivalent of Docker. It's what you'd see on Linux. It's non-commercial, but it's exactly, if you just do an ln and link Docker to Podman, it's exactly the same thing. As far as we're concerned for this talk, handwavy, exactly the same thing. Docker build -t, and then whatever I want to build, or Podman build -t. And it goes through, because of time, I'm going to hand wave a bit more, just to say it's doing things super interesting because of layers here. Each one of these is like a little tiny hard drive that's a copy on write from the previous hard drive. If you know what LVM snapshots are, just imagine you have a base snapshot and something else that's slightly different on that snapshot, and something else on that snapshot. So you can, if this snapshot doesn't change much, you don't have to keep pulling it. You don't have to keep adding it. Anyhow, I'll hand wave that. It's not part of the talk, but just know that you want to keep these tiny to keep this more efficient, and we can get into details there as well. This is my incredibly sophisticated program. What do you think? Rocket science? You guys think we can? What do you think that's going to do? The question just came up, does Podman replace Docker? Podman and Docker are the same thing. If I don't want to install Docker and I want to install Podman, yes, I could use them exactly the same. But if I want to pay for a Docker license and I actually want the Docker support, if I want Docker for whatever reason, I could use Docker instead. So all very good. All right, but what are we going to do here? I am simply going to, and somebody obviously Interesting. All right, so very, very sophisticated stuff. And here it goes run. Notice I'm going to run that container interactively, but because I forgot to take it out. I don't need this. I'm going to say that's the latest image. It's a lot like Git in this way. And this is the program I'm going to run. And it actually is running it from inside the container, but snipped out for the slide. So I could theoretically run every single one of these in the container. Quickly, because I'm over, keep the container small. We can talk about what that means later. The number of layers small, don't use multiple run lines, use one run line. Each run line because it's on layer. So one line with a lot of ands will actually make that more efficient if they don't change, which is what you're looking for. The things that don't change the most, put first. Your container is really an independent piece of your project. Connect your containers together for Docker Compose, and it's interesting what's the equivalent of Docker Compose for Podman? Big talk. Someone learned something tonight. I promised you. Excellent. Very, very good. And then push your container images to a repository. You actually need to put your container images somewhere. Think about this just for a second from the Python world. I need to install some sophisticated science project, but I get all these compile errors. I need to go to PyPI and pull this. I need to go PyPI to, why do I need this particular compiler over here? How does that scientific library not work over here? Wait, how does that work? I don't understand what's going on. You could, theoretically, if we were to organize ourselves and have one way, not a million of us doing it different ways, have different containers already defined that we could pull from our own common Python place that had all of our packages that were pretty much packaged in a way that we could use them. For example, SciPy, if it's still being used, SciPy, that's already there. I pull the image and I run it. It really is as easy as just, running it interactively or running something else. Just an idea. Think about that. We are far from that. But if that were something that we had that was organized, that would be an idea to think about. You want to know more about Docker? There's a whole great course. I find Brett Fisher stuff the best. I really like him. That's not Brett Fisher, just so you know. And it's a Udemy class. This was in the slides. And the answer to the question before is like, what if I want to put the containers together? Well, this is all about orchestration and connection, and that's what Kubernetes does. And Kubernetes is ruling the world when it comes to the one way to do lots of different containers when it comes to big companies. For a small company, I'm not sure. It's very, very big. It has a lot of space. I personally am not convinced that Kubernetes is the right answer here. For small, tiny companies, it's very good at what it does, but it's very big. And for you have a 5-person company, I think it might be a stretch to say Kubernetes installs wouldn't leave an attack vector open because people don't have time to do it right. Either way, discussion. Give me another drinking break. Which is one of these is the right way? pip-env, poetry, or pip tools? I warn you, it's a trick question. Jeff, let me know if I get too far over. I promise I'm going to wrap it up as quickly as I can.
Doing great. Really interesting.
So KATES, as somebody is putting out there, thank you, Ryan, is actually the abbreviation for Kubernetes. A lot of us try to write K8S. KATES, it's very, very cool. If you would have asked me the answer, I would have said poetry 2 months ago. But an answer I got at PyCon was actually containers with pip tools. And I was like, what? Because poetry works well. All of my projects are still in poetry. But what if I were to use pip tools, which, by the way, there's a whole talk on that. It's very simple. This is a newbie nugget, not really a full talk. If anybody wants to know pip tools, it's much smaller than the other two. If I did my own containers with pip tools, then everything I would do would build that container for everyone, and we already have it in a repository, and it would be super simple, and they would be one way. I would no longer have to try, even though poetry is very good, I wouldn't have to set up my virtual instance. I wouldn't have to pull all that stuff in. I would have to try to get this particular binary to work. We would all have the same container. Just talking. It's a nice idea. All right. Well, let's tell you just how over time am I? 2 over. All right. Lots of vendors, too much stuff. My customer. Let's tie this story back together and let you all go for the day. All right. AWS was already there. They were already on containers, so half of that was gone. They're on they were wanting to use Fargate, not Kubernetes, because they were already using Amazon in a particular sense, but not use EC2. So we took a long way to get here, but the idea was, I saw us really like not knowing, like at one point in a particular talk before COVID, we're like, what's a container? I wanted to get us all the foundation to understand this particular journey that I went through. They wanted information as code, and they really liked what they read about Pulumi. Their marketing for Pulumi is actually very, very good. By the way, I forgot to put this up there. All the Pulumi stuff is copywritten by them. There's no open source for Pulumi. It's all copyrighted by their stuff too. I forgot to put that argument in too. Anyhow, I did not choose this, even though that was excitedly why I was going to pick the talk, but I figured I'd go through with the talk anyhow. It wasn't declarative. Even though it had declarative pieces like another tool called Terraform does, you wrote a lot of pieces on your own. And that was exciting to me. It's like the idea of Ansible, but in a very clear outside face. I think there's something super exciting about that. I've been thinking about that for a very long time. But it's kind of moot with a lot of what I saw at PyCon and containers. Old dog now. I've got to learn new tricks. See, now I can justify the dog, although he's a young dog. My customer did not understand infrastructure as code. They thought they did, but they were such a programmer mindset that they were like, I could just see like, oh, keep the sharp, pointy, shiny pieces away because it's just going to cause I would lose money on that one if I didn't bill by the hour for sure. I did love the promise of this declarative outer shell, like I mentioned, and this inner thing of just being able to write your custom pieces. But it wasn't that, and it wasn't open source. So I picked Terraform because that's what I knew. How many times I've already built all of my sites in Terraform like this, all of my infrastructure with Terraform. It's very declarative. It's not Python based. It's actually written in Go, sorry. But it's describes what's the systems. I still use Ansible for all of my internal systems, but for the EC2 or containers or the VPCs or all of that stuff, I was using Terraform. In fact, I'm writing tools so that anyone can just take these boilerplate VPCs and build their own. It worked well with AWS and it was the best solution. So what is the one way? I believe as we go forward, the one way for infrastructure, I don't know. Terraform maybe, I don't know. But actually containers for sure for us in Python. I believe containers and pip tools is our one way and that we just have to work to get there. I'll quickly say as I'm closing up, I'm still struggling with like what the one way is. I'm sure somebody here is going to argue with me saying, no, Google's cloud platform is so much better than Amazon because of X, Y, and Z. I would love to hear your arguments. Not for a real arm wrestle, because I want to learn and grow and make one choice. Ideally, I pick my customers and I have them one boilerplate so they don't have to learn all of this. They're a new startup. They're seed funded, but only one round. They don't have a lot of money. They're between 3 people, which I have seen, and 1,500 people. So what tools make sense in that framework? What do you stick with? What makes sense for them to go after that? I would love to have a blueprint document, a blueprint organization of pretty much everything about what would make sense for the one small customer. I have office hours and a talk. Jeff, I turn it over to you. Oh, let me quickly say, you don't have to remember a lot. GlenJarvis.com, a lot of Ansible stuff there because that's what I've done for so much. J for jump, talk. It'll take you straight into a Discord. And if you want to find times to go over those demos and office hours, channel's open for you. We'll pick a time. I'll help you do EC2, Boto, I mean. I'll help you do Ansible. And that, by the way, is not in the repo. I didn't finish that one. I will help you do more containers and learn more as we go together. Also, this talk, just GitHub, Glen Jarvis, it's pinned. That's all you have to think about. Jeff, it's yours.
Well, thanks a lot, Glenn. That was really great. I can do a physical clap. Does anyone have any questions?
Quick question, Glenn. What do you recall what the talk was that you watched for that pip tools and
it wasn't actually in the talk. It was actually in the chat that we were doing online along with the talk. It was a packaging talk. I wanted to, what's the one way to do packaging? We've been fighting over VENV, PipEnv, and poetry, and I found poetry the superior of the two of those. But there were still some, some opinionated pieces that kind of kept. There was still some arm wrestling going on, as we see for everything that's pip and packaging. And the chat there, people pretty much said, look, really, the final answer is containers and pip tools. And I'm like, I don't know what piptools is, but I start right now. And I learned it. It's pretty quick. I don't remember the exact talk. I'll find it and send it. Why would someone use Fargate over EC2 is a question that comes up. Fargate itself, Amazon runs the containers. You don't build a machine. You don't build a virtual machine to run the containers. You just send your containers to Amazon and they'll run them when they're being used. In fact, think about those Amazon Lambdas that we were doing. You had a Lambda function where you had a function in the cloud. My function wasn't being used forever. But when I did, I'm sure it started a very tiny container, which is super fast to start out, ran the function and closed it down because it has a whole bunch of its own servers just running our containers whenever we ask for it. So it's now a service. It's running our containers as a service where I no longer care about the virtual machine. So that's why I would use Fargate. ECS is a good question as well. ECS is two different ways. Elastic Container Service. I can't remember what ECS stands for.
Yep,
Someone
that's
look
right.
it up and tell me. Huh?
That's right.
Elastic Container Service. There's two different ways of ECS. ECS handles your containers for you, but you manage it. You have two different ways of doing it. You manage it yourself with your own virtual machines behind the scenes doing all the stuff I just mentioned with Ansible. Or you can say, yeah, I want to use ECS, but let Fargate handle it behind the scenes. So ECS and Fargate can be used together where basically it's like you're doing all the containers, but I don't need, I can use my own VMs in ECS, or I can say, nope, Amazon, you take care of it. And that's what Fargate part is.
Oh, rad. Thank you.
Sure.
So I got a question for you. How much harder is it to get from, say, like your single app Django Rest Framework server to like a typical Django stack where I would imagine I have a load balancer, multiple Django nodes, and a database?
It's a trick question. Theoretically, it should be a single click.
Okay.
Amazon has their own cloud templating that we could use. There's Terraform, which works as well. I still don't know what one tool is going to be the best to describe that infrastructure. Theoretically, and that's kind of what I'm trying to do with anyone who joins me in this blueprint project, is help wrestle over what the one answers are for most of those things. I would say theoretically it should be a single click. Practically, you're probably going to run into something silly and it's going to take a long time. So yeah, the best answer I can get. It really depends. If you've done everything containerized, if you already have your container set up, if you do some of the stuff out of the box, probably can happen. But my guess is we still have some stuff to learn.